Hello. Hopefully many of you saw my other Flatpak talk yesterday. If not, the introduction to Flatpak in this one will be even more introductory and in a bit of a rush. This is the 2-minute version of my 20-minute talk yesterday. Sandboxed app framework for desktop Linux. It's for the sort of thing you might get in an app store. It's also for the sort of thing that might have a desktop file. Your app runs in a sandbox because you don't want it reading your PGP key. There are portals, which are a clever mechanism to escape from the sandbox to do things like access a file that the user has chosen without having access to all the other files that the user didn't choose. And they use essentially the same Linux syscalls and so on as more conventional server container technologies like Docker, LXC, that kind of thing. And the thing that is important for how these relate to distributions is that an app runs on a runtime. So the idea of a runtime is a Linux distribution is fine as a stable platform, but if you want your app to run on Debian and Fedora and Debian from this year and also Debian from 5 years ago, you don't really know what you're going to get. So a runtime is like the API compatibility levels you have in Android, where you can say this app is going to run on Debian 9, and the infrastructure gives you an appropriate runtime to run your app on. So the app author gets to choose when they update. They can update at their own pace once they've done whatever QA they feel is appropriate. The runtime comes from what Flatpak calls a branch, where the idea is the major version, and depending on your policy, maybe the minor version is fixed at a constant, but you do pick up micro releases for bug fixes, security, that kind of thing. You definitely don't update it across incompatible changes because that defeats the object, and you have some kind of lifetime for which this runtime is supported. So you might have, will support this runtime as long as the underlying version of Debian, so 2 years or 5 years or whatever. And this all sounds kind of familiar to people in the distro's dev room, I'm sure, because this is basically a tiny Linux distribution. It's a weird Linux distribution because it can't boot. You don't have a kernel because you have a host system for that. You don't have init because you have a host system for that. There is no sysadmin things because you're running as one user, you're running an app, you don't need daemons. In the version that users see of the runtime, you don't have development tools because if you just want to run events or Firefox or Steam or whatever, you don't need GDB. And there is also no package manager because version management and uninstalling and upgrading and all that kind of thing is done from outside. So instead of running apt inside your container, like you might with Docker, you essentially throw away your container and put another one in. And obviously it's deduplicated. You don't actually download everything again, but conceptually it's as though you did. So the first thing I want to talk about is why you might want your distribution to have Flatpak and not just go, well, we've never needed this, we never will need it. One thing that's often really annoying on long-term stable distributions is when you want a stable platform to do your work on that will not change under you and give you arbitrarily different UX, except that there are these 3 apps that you absolutely need the latest version because they're important to you in your job or whatever. So you might be running on one of these very enterprise distributions that's supported for 5 years and it's not allowed to upgrade anything because you want that predictability, but you absolutely need the latest version of maybe Inkscape or something because that's the thing you're specifically interested in. And as an upstream developer of an app, you kind of have this nasty duality that if you depend on new libraries it's going to be really annoying for your users to install them on Debian from 2 years ago, or Red Hat Enterprise Linux from 5 years ago, or whatever. But if you choose to like artificially restrict your dependencies and say, well, I'm only going to use the version of glib that was in Debian 2 years ago, you don't get the benefit of all the work that's been done since then. And, you know, as we know, 2 years is an eternity in software, so you probably don't want that. So distros have generally dealt with this by backports. So like in Debian, we have the stable backports branch. And lots of other distros have similar things. So you choose your selected software, mostly like leaf packages like an app or a game or maybe a server, and you take the version from the next development release, you rebuild it for the previous stable release, and you cross your fingers and you hope it works. And if it hasn't actually got new dependencies, like a lot of games, you can just backport by 5 years and they'll be fine, because they don't require much from libraries anyway. But if you do depend on newer libraries, because you only have one copy of like libgtk3 on your system, you have to make this unpalatable choice of, do I want the predictable one or do I want the latest for my backport? So for instance, if you have a backport of AbiWord, which depends on GTK, it might pull in a newer version of GTK, okay, fine. But now all of GNOME is using that newer version of GTK, and maybe you've just destabilized your entire desktop environment, which is probably not what you want. Or even if you're like happy with backporting the entirety of GNOME, like I believe Red Hat Enterprise Linux does sometimes, if you've decided that's something you're willing to do, you upgrade your glib to be able to do that, but you can only have one copy of glib on your system, and thermald, that stops your CPU overheating, also uses glib. So if there's a regression there, then your laptop cooks itself and you're sad. So the reason I was like originally interested in Flatpak is to be a better backports, because backports, as currently done in distros, have this problem with you have to make a choice. But if you can build each app, each game, each leaf package against a stack that its maintainer is happy with, not necessarily the same one even, then you don't have to make this choice. You can have one choice of runtime that you run on for GNOME Builder if it needs the latest shiny GNOME things. If Inkscape doesn't need really recent stuff, you can run it on a different runtime. You don't have to choose a single answer. And each upstream app author can choose the pace they upgrade at, and not be forced into, well, we have to use this new version because this other app wants it. And obviously, the immediate worry from distro people is, but we don't like duplication. And yes, your libraries will be duplicated a bit, that will happen. But there's less than you might think, actually, because Flatpak uses OSTree, which is essentially Git for binaries. So it's content address storage. And if two of your runtimes happen to contain the same thing, like you have a GNOME runtime and a KDE runtime that both include glibc, you only actually have one glibc on your, if it's the same one, because they're just hard links to the same file in the hashed storage. Another thing that's quite interesting for Flatpak on a distro is the diametric opposite of that. If you have software that depends on libraries from the distant past that we would all rather had died, like the GNOME 2 stack, which we're finally removing from Debian at the moment, you don't really want to carry those in your distribution forever, because your users might have an app that wants like libgnome GNOME VFS or libunique or whatever. And a lot of the time the distros don't really have the resources to maintain them forever. And to be honest, they were deprecated for a reason, right? No one just says this library is obsolete for fun. It's because they found a design flaw and they can't fix it without breaking compatibility. In particular, Collabora has been doing some work recently with Valve on Steam, and they have this problem in a big way, because they distribute binary games, which ideally the publisher doesn't want to touch them once they've got them to like an acceptable quality. They want to go, right, this game has gone gold, throw it out the door, we're done with this one, move on. And like maybe patch it a few times later, but they don't want to keep going, oh well, this doesn't work on this year's Ubuntu, we'll have to fix it to work with this GTK. And now it doesn't work on the next year's Ubuntu, let's fix it up for that. If someone's complaining it doesn't work on OpenSUSE, it's not really viable. So their solution to this has been the Steam runtime, which is Ubuntu from 2012 with selected backports, which is two words that cover a multitude of sins, I'm sure. And it's a giant LD library path to pull in libraries of selected versions. And all the games run in this. The Steam client runs in this as well, because it has stuff that would potentially break with a newer GTK or a newer, I don't know, libjpeg or something. But it has gaps. It specifically doesn't have its own graphics stack, because if you have an NVIDIA binary driver or a Mesa open source driver that works for your hardware and that corresponds to your kernel, they want to use that one. They don't want to use some other version that may or may not work on your machine. So it's like this incomplete runtime. And what we think might be a good way forward here, which we're still experimenting with, is put each Steam game in a container. So I have this tool called FlatDeb, which is a proof of concept for building a Flatpak runtime out of Debian or Ubuntu packages. So the Steam runtime, we have a pile of .debs that are perfectly reasonable. We just need to unpack them, put them in a container, use those. My colleague Vivek is working on this terrifying thing called libcapsule, which, if you're interested in that, he did a talk on this which was recorded at last year's mini-debconf in Cambridge. That lets you load libraries of the same name with the same symbols into the same address space without colliding. It's glibc black magic, and the idea is that you can have your game's dependencies, which probably include the standard C++ library, because game developers love C++, and you have Mesa, which uses libllvm, which uses C++, and a different standard C++ library, and somehow you need to get both these in your process space without them fighting. And this is the idea of libcapsule, and it almost works, which amazes me. As I said, work in progress. And in future, at the moment, the entire Steam environment runs in one copy of the Steam runtime, essentially. The UI where you buy your games, and the library, browser, and the launcher, and the games themselves. In future, what we would like to do is have old games that have never been QA'd against a new distribution, keep running them in the old runtime. New games that the developer has tried them against newer stuff, maybe they even need newer stuff. We can run them in a less old Steam runtime, like maybe based on a more recent Ubuntu or on the latest Debian stable or something, and pick one or the other, whichever works for the library browser and that kind of thing. There are a few unsolved problems with forward ports, I have to say, and I can see why distributions might not like the idea. I mean, if you have some unmaintained libraries and you put them in a runtime, that doesn't magically make them maintained. Someone still has to either do the work or acknowledge that it's not going to be done. And in particular, Ubuntu 12.04 was EOL last summer. I mean, it's a long-term support distribution, but there's long-term and there's long-term, right? But if you're going to use this anyway, and Steam is in production using a pile of libraries anyway, we can at least sandbox it, and that's got to count for something. It's better than not sandboxing it. And it's way better than a static binary, where you can't update it even if you wanted to. And it's infinitely better than what people tend to do in practice, which is go to archive.ubuntu.com, wget ancient library, don't use secure app, just install it, cross your fingers. Yeah, don't do that. Another good thing to do is software that isn't yet in your distribution, but you would like to use it anyway. So some distributions are more complete than others. Debian tries to have everything. Even we don't package everything. And the idea is, ideally, we want everything like held to our quality standards. But maybe that's just not feasible, and maybe we should let the perfect not be the enemy of the good here. Because, you know, in an ideal world, we have enough maintainers for doing all these things better than upstreams can, you know, keeping everything up to date, not QA to make it not regress, making sure the licensing is actually reasonable, and that kind of thing. And at our best, we can protect our users from bad software. But sometimes we don't actually add value. You know, I'm sure there's plenty of packages in everyone's distribution where the entire changelog is like new upstream version, new upstream version, new upstream version. You're not actually adding a whole lot to that package. And sometimes having like a gatekeeper is just stopping people doing what they want to do, which is not great. So I said a couple of slides ago that Debian tries to package everything, apart from that whole free software thing. So some distributions very much want to steer clear of proprietary software, but we kind of have to acknowledge that our users want it. And ideally, we should be like mitigating that and protecting the rest of the system from deficiencies in the software that we can't fix. Hey, wait, we have sandboxing. Good idea, right? And I was talking about free software there, but sometimes it's not even about freedom, it's just about quality, which, you know, you might think of the same thing. Some software is really niche, and maybe it doesn't make sense to package it for even Debian, but you want it anyway. Some software is, to put it bluntly, really awful, but maybe you need to run it anyway because, like, it does something critical for your job or whatever. And surely someone packaging it is better than you can't have it. Particularly if you can sandbox it to mitigate if they've done it wrong. So, one thing that you get with Flatpak, if you choose to enable this, is FlatHub, which is, the idea is it's like the App Store or the Google Play Store equivalent for Flatpak. You don't have to enable it, but the expectation is you probably will, and it's a good place to get a lot of stuff. So there are some reference runtimes targeting common library stacks. There's upstream software packaged by the upstream developer themselves, which is like the ideal case. We want upstreams to maintain their own because they know it best, hopefully. And also software that is not packaged by its upstream, maybe even proprietary, maybe even non-distributable, packaged by the community. This is all tagged with license information, so if you're worried about like Debian free software guidelines or whatever, you don't have to display all the proprietary stuff, but you can if you want to, if your user opts in. And in some cases, FlatHub isn't actually allowed to redistribute things, so what they distribute is a script that knows how to download it. So for instance, this is how the NVIDIA drivers work, I believe, that you install a sort of stub Flatpak, which then goes and gets the right driver for you. So hopefully distributions would quite like to have Flatpak. Distributions can also help Flatpak out. The most obvious thing is make it easy for your users to get it. If your distro doesn't ship it, then you're kind of stuck. Also, the portal mechanism, which I spoke more about yesterday, you really need the portals to be available on the host system, otherwise apps will just not work, because you know, it's like, okay, I will go and browse for a file, and wait, the file browser's not there. No, that's not going to happen. So for distributions where their policy allows, following the stable branches provided by Flatpak Upstream is an excellent plan. I'm doing that where I can in Debian. Backporting the latest versions can be a good move too. I know I said backports were terrible, but in this case, kind of a necessary evil. And so other components are picking up support to be used kind of like portals as a way to get like controlled access outside the sandbox without giving like blanket access to everything. So I'm currently working on some stuff for Dbus Daemon, which will come in the next like year or so, hopefully. There are some plans for improving how dconf works so it can behave a bit like a portal, that kind of thing. And if your distribution makes those available, great. Runtimes. Runtimes seem quite familiar, but because they are essentially a distribution. So, and this is the distros dev room. We know this, right? We know how to put together libraries that are compatible, apply security updates, not regress, we hope. So maybe having distros be like a curator of this is a good runtime with compatible versions of GNOME is a good move. Another thing distributions are often very good at, because they've kind of had to be, is making sure you're complying with all the relevant licenses. So Flatpak Builder helps you with this, because when you build your app or your runtime, it makes another distributable module alongside it in the same Austria repository, which is the corresponding source code. So whatever it compiled, it commits that as well, so that if you just blindly rsync the result to your mirror, you're distributing binaries and you're distributing source for those binaries. Yay. But obviously not all our upstreams are amazingly good at complying with their licenses, and sometimes there's like licensing oversights and missing copyright notices and whatever, and some distros are more strict than others. So, you know, ideally, if you're fixing this sort of stuff in your distribution, please tell your upstream about it. If you can get that fixed once there, we all win, and we have to spend less time rummaging through licenses and hating our lives. So as well as runtimes, distributions might be a good source of high-quality apps, and in particular, not all upstreams get their apps right. Like some upstreams, naming no names, are not very good at releasing security fixes. They'll like commit them to Git master and then never do a release. And distros pick up the slack there. So hopefully we can do the same for Flatpak, provide good apps. So Fedora, I believe, are planning to essentially take all their Leaf packages, mechanically turn them into Flatpaks, publish them. So yeah, ready-made source of good apps, hopefully. And other distros, I'm sure, can help with this sort of thing. Fixing apps, yeah, I talked about security fixes, but just any serious bugs, really. Same kind of thing. If you can send stuff upstream so that it gets into all the other distros and it gets into the Flatpaks, that will help a great deal. And if your upstream developer is not helping you out with this, maybe routing around them is kind of necessary, and talk to the other redistributors of your app and try and get stuff fixed that way. I was going to talk a bit about places where you can't use Flatpak, but I don't think I have time for any detail on this. But basically, if it's not an app, it's not Flatpak. Use a different tool, and I can talk about this more afterwards if people are interested. Thank you.